So now in this video, we are going to measure the Idss of these two JFET transistors right there. It's going to be in the milliamp range. We can go up to 600 milliamps with this setting. We don't need to move the red probe for anything but high current. And so I can just set it to milliamp. If there's numbers, set it to a number that is higher than what you are going to measure. Now, we have the gate down at the bottom right there of both of these transistors. Again, they're the same component, but they will likely have different IDSSs. So gate down at the bottom, and then we tied the source to the gate with that jumper. We could put a resistor there to set a current lower than what the IDSS is if we want to. I might do that next video. So in any case, we're going to bridge the gap from positive supply to the drain. Positive supply, drain, or you could go across, either way. As long as you're somewhere on the positive supply. Coming to drain, you'll measure the current of the IDSS. So again, this is in milliamps of current. I have the power supply set to a maximum of 100 milliamps because these components should not go above 60 milliamps. And there you can see that one's like 34. And interestingly enough, it looks like it goes lower in current as it warms up, but it should level off at some point right there. But we're not going to wait that long. See where it levels off. Just remember, we could set it significantly lower than this, and it should hold steady if we have a load or the source to gate resistor right there. But a load, light load, would also help. So there, you can see we had like 40. And that's more than I want to put through an LED. It'll probably be bad for the LED. So we're not going to. Always turn off the multimeter when you are done, especially if you're measuring current. So now I have this diagram right here. This is a symbol I like to use for the N Channel JFET right there. There's other symbols that you could use. It's not as varied as the MOSFETs, but the JFETs are still not universal symbols. I tied the gate to the source as I mentioned before, and the drain we measured the current from the positive supply, much like you see there. And we'll zoom in and look at the pin layout. So for the J310, other JFETs may have a different pin layout. This is the only one I got. Left pin's drain, middle pin is source, and right pin is gate. They may be numbered too, like on a data sheet. So yeah, we got a gate down there, source in the middle right there, and there's a little jumper connecting the source. We could replace this with a resistor, as we'll look at in the schematic coming up, and then drain right there between the positive supply. So as I said before, I got the schematic for getting the IDSS. Now when you see SS, that means that the source is directly to the supply voltage. And I wrote that down there. Doubled up sets are used when referring to direct connection to a power source. So like you see, VCC, that means the collector side of the circuit, especially if you connect it directly to the supply. But in this case, SS, the source, is absolutely directly to the supply when you're measuring the IDSS. So that's the current when the drain and then the source is connected directly to the supply. We could add a resistor right there, so it's not SS anymore because it's not connected directly to a supply. So we would just call this a current sink. That's because the transistor is on the lower side of the load. And so if the transistor is on the higher side, that would be closer to the supply. Then it would be a current source. But here it's closer to ground, so we call it a sink right there. But you could add some resistance to lower the current below the IDSS, and so it's adjustable. The amount you add will lower the current. Current is not set by the load as long as you have the voltage to power everything. Remember, the load, not a multimeter, but an actual load, is going to take up some of the voltage. But as long as it doesn't limit current more than what you already got here, this will set the current. Hopefully that makes sense. So it makes a nice two-component current source. Pretty easy to do, but again, you got to live within the limits of the component. So you could go up to 25 volts, but just checking the IDSS would get really hot. You want a load to take up some of that voltage, because in this example, we had about 30 milliamps right there through this one here. We were getting somewhere about 0.15 watts, probably a little bit higher. So it got quite warm, and as we saw, it was like starting to limit current, which is a protection thing. Thermal runaway would be when a transistor conducts better as it gets warmer, and that can get dangerous because the wattage is going up as it conducts better. So you'd want to take away some of the voltage to help cool down the component. But again, we're getting well above 20 milliamps of current, so I don't want to add an LED right now, which is the easiest way to lower current. Maximum wattage is 350 milliwatts. So when we were getting 40 milliamps, that was getting us to about 200 milliwatts, you know, quite warm. Usually want to stay below half of the maximum wattage of stuff. But if you're looking at a data sheet, it'll say P, D, and then voltage across the drain and source up to 25 volts maximum. Now, we have the J310. So the Idss, according to the data sheet I looked at, could be as low as 20 milliamps of current, or it could be up to 60 milliamps of current. If you have enough of them from different batches and stuff, you'll probably end up in that full range, everywhere between 24 and 60 milliamps of current. So it's not exact for the particular component. Each component is individual. Once you know its maximum or its Idss, then that should remain pretty steady for that one, unless the heat damages it a little bit or something. But there's variability even with the same component, but the largest variation, the range of variation, is set by the component type. So in any case, I think I pretty much covered everything, so I hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the link down below. They all help out a lot. I'll see you in the next video.